Hi, this is MD Shavana Sultana, working as Associate Professor in Chevron Engineering College, Chevron. Today I want to discuss about theories of corrosion. In the last lecture, I explained about what is corrosion, what is a cause of corrosion, and what are the consequences of corrosion. Today I'm going to discuss about the theories of corrosion. Theories of corrosion, it is also known as mechanism of corrosion. Broadly, the mechanism of corrosion takes place in three types. They are dry or chemical corrosion, wet or electrochemical corrosion, and the last one is confirmation of the mechanism of corrosion. In that, first one, chemical theory of corrosion. This chemical theory of corrosion is also known as dry theory of corrosion. In this, metal undergo corrosion by the reaction with air in the absence of moisture. It is called dry theory of corrosion or dry corrosion. In this, the corrosion occurs mainly through the direct chemical action of the environment or atmospheric gases such as oxygen, halogen, hydrogen sulfide, sulfur dioxide, nitrogen, and anhydrous inorganic liquid with the metal surfaces. In this type of corrosion is again classified into three types. They are corrosion due to oxygen, corrosion due to other gases, and the liquid metal corrosion. First one is the corrosion due to oxygen. In this, mainly alkali and alkali earth metals. These group elements are mainly responsible for the formation of corrosion by the reaction with oxygen in the absence of moisture at room temperature. And the direct attack of oxygen which takes place on the metal is known as oxidation corrosion. Generally, the metals are oxidized to a smaller extent, but alkali metal like lithium, sodium, potassium, rubidium, cesium, and francium, and alkali earth metals are beryllium, calcium, magnesium, strontium. They are very rapidly oxidized at the low temperature, except the silver, gold, and platinum. Almost all the metals are oxidized at higher temperature. See, these metals react with oxygen at high temperature to form metal oxide film. In this type of corrosion, rate of the corrosion depends upon the nature of the metal oxide film. What type of metal oxide film it is formed, on that basis only the corrosion will depend. Coming to the nature of the metal oxide film, they are again classified into four types. They are stable, protective, non-porous metal oxide film. Second nature is unstable metal oxide film. Third type of nature metal oxide film is a stable, non-protective, porous metal oxide film. And the last one, but not the least, it is a volatile metal oxide film. Coming to the first type of the metal oxide film, which is a stable, protective, non-porous. Non-porous means it is a substance which does not allow the liquid or the air to pass through it. In that way, it does not allow any type of gases to pass through this film onto the metal surface, and it acts as a barrier to prevent the contact between the inner surface of the metal and the air. In that way, this type of metal oxide, it prevents the further rate of corrosion. And the example for this is the oxides of lead, aluminium, and tin. They form very stable and non-porous metal oxide film. Coming to the second one, that is the unstable metal oxide film. Unstable, that means as soon as the metal oxide film is formed, they undergo decomposition. Due to this, the metal never participates in the corrosion because it decomposes soon after its formation. The best example for this is the gold and platinum. And third type of metal oxide film is stable, non-protective, porous metal oxide film. This type of metal oxide film is formed by the metals of alkali and alkali earth metals. They have the porous nature. Due to this, the air molecule through the porous hole, they enter and interact with the inner surface of the metal, which increases the rate of corrosion continuously till the total metal is consumed. Coming to the fourth type of metal oxide film nature is volatile metal oxide film. Volatile, which becomes evaporated soon after its formation. The best example for this is a molybdenum. It forms the metal oxide film and it increases the rate of further corrosion. To express the extent of protection given by the corrosion layer to the underlying metal, filling backward rule was postulated. According to the filling backward rule, the smaller the specific volume ratio, that is, specific volume ratio means volume of metal oxide by volume of metal, which is greater is oxidation corrosion. And it is explained as follows. If the volume of metal oxide film is at least as great as the volume of the metal from which it is formed is non-porous and becomes protective layer by tightly adhering to the base metal from which it is used. no corrosion occurs as the oxidation of the metal reaches to zero. For example, the specific volume ratio of chromium and nickel are 2 and 1.6. The rate of corrosion is least in the tungsten. If the volume of metal oxide is less than the volume of the metal, this one, the volume of metal oxide is less than the volume of the metal, the oxide layer is porous, non-continuous, and non-protective and faces stains. Hence, cracks and pores are developed in the area, creating access to atmospheric oxygen to reach the underlying of the metal. In this case, the corrosion is continuous and rapidly increase. The best example for this is lithium, sodium, and potassium. So this is about the nature of the metal oxide, which is expressed in terms of Killing-Bedworth rule. And next, coming to the second type of corrosion, that is corrosion due to other gases. The metal undergo corrosion by reaction with the gases like sulfur dioxide, carbon dioxide, chlorine, H2S, and also cause chemical corrosion. And the extent of corrosion mainly depends on the reactivity to the gas on metal surface. That means the corrosion product is the metal compound. The nature of the metal compound determines the corrosion. For example, if you take the corrosion film form is more than the underlying metal. It is strongly adherent, non-porous, and does not allow the corrosion gas to reach the underlying metal. Hence, it is a protective film and does not allow the corrosive gas to reach the underlying metal. For example, the attack of chlorine gas on the sulfur metal produces the adherent, non-porous silver chloride film, which is protective. If the corrosion layer has less volume than the metal, then stain is developed on the layer to produce the cracks and pits, creating access to the corrosive gases to reach the underlying metal. Thus, the whole metal is gradually destroyed. For example, if we take the chlorine, attack the tin. This example. If we take the chlorine, attack the tin, forming the volatile stannous chloride. I already told you it is volatile, which evaporates immediately, leaving the fresh metal surface on the surface attack and the further attack. H2S gas attacks the steel in petroleum industry, forming a porous FeS layer, that is iron sulfide layer, which further increases the corrosion. So this is about the corrosion due to other gases. Coming to the last type of corrosion, which is known as liquid metal corrosion. This type of corrosion takes place when the liquid metal, there is the best example for this is a liquid mercury. When it passes on the surface of the another metal, then corrosion will take place. That means the chemical action of the flowing liquid metal at high temperature on the solid metal or alloy produces liquid metal corrosion. The reason for the corrosion is the dissolution of the solid metal by liquid metal or internal penetration of the liquid metal into the solid metal, weakening the solid metal and causes the corrosion. Best example for this is liquid mercury metal. It causes the corrosion to almost all the metals. And the second example is a sodium metal. It causes the corrosion of cadmium rod in nuclear reactor. So this is about the dry theory of corrosion. Coming to the wet theory of corrosion, this theory is also known as electrochemical theory of corrosion. The wet theory of corrosion is also known as electrochemical theory of corrosion. And it takes place under the wet or moist condition through the formation of short circulated electrochemical cells. And wet corrosion is common than dry corrosion. And in this, when the metal exposed to the environment along with the moisture, it undergo corrosion due to the formation of anodic and cathodic region on the same metal or between the two metal surfaces in the presence of moisture. This is a very important. In the presence of moisture is called wet or electrochemical corrosion. In this, the moisture, which I took it is important, this acts as a conducting medium. And I already told you that anodic and cathodic regions are formed. And these anodic and cathodic regions are formed due to the following factors. When the metal is in contact with the conducting liquid, whatever this conducting medium we are taking, when the metal is in contact with the conducting liquid, then the anodes and cathodes are formed. And the second factor is due to the formation of oxygen concentration gradient due to differential aeration. And when the two metals are in contact with each other, when the metal surfaces are subjected to strain. Coming to after the formation of the anodes and the cathodes, what are the reactions takes place at the anode and cathode? The same concept which I explained in electrochemistry, that at the anode oxidation takes place by the release of electrons and the metals are ionized to its respective ions. There is a reaction takes place at the anode. That means at the anode, metal undergo corrosion to form metal ions by the release of electrons. That electrons are migrated towards the cathode by using that moisture which acts as a conducting medium. So your example is iron that gives rise to this is ionic form of iron Fe+2, which is in the ferrous form. with the release of 2 electrons. And at the cathode, the reduction takes place depending upon the nature of corroding environment. This nature of the corroding environment, it takes place in the absence of oxygen or the evolution of hydrogen. This is a one factor. In the acidic medium, this type of corrosion occur usually in the acidic environment. The rusting of iron takes place in acidic environment in the following way. At the anode, hydrogen ion absorbs the electron to form hydrogen gas. With the absorption of electrons. In the alkaline medium, the water absorbs the electrons to form hydroxide ion and hydrogen gas. And next one, in the presence of the oxygen, oxygen absorbs the electron in the presence of moisture to form hydroxide ion. Then these hydroxide ion react with the metal ion, which is formed at the anode to form metal oxides, which forms yellow colored substance called yellow rust. Thus, the rusting of iron takes place by the diffusion of the ferrous ion at the anode and hydroxyl ion at the cathode when they meet to form the ferrous hydroxide near the cathode. If enough oxygen is present, this ferrous oxide undergo further oxidation to form ferric hydroxide, which forms reddish brown color precipitate called the rusting of iron. That brown color precipitate is due to the formation of this ferric hydroxide, which may be represented as like this. In that way, the rusting of iron takes place at the anode and cathodic area. Next one is the types of corrosion, which I'll explain in the next lecture. Thank you.